Welcome to this webinar about geospatial machine learning operations, also known as ML Ops, and how it can empower organizations of the future. Well, I'm very excited to have you all here in this new webinar, and also excited to be joined today by one of our clients, Scient, and they will be sharing how they use such frameworks to help them organize and gain more value internally, and adding how Pictera ML Ops enables their geospatial practice. So let's get started. First up, of course, introductions. My name is Joy, and I'm an account executive at Pictera. And I'm very pleased to be joined today by Yaj, who is an Earth observation consultant from Scient. So Yaj.
Yeah.
Oh, yeah. Here you go.
Hi, Joy. Hi, everyone. A very good morning, afternoon, and evening to all of you. Thanks a lot, Joy, for inviting me here for this session. And it's a real pleasure for me to be able to share my experiences in recent times, specifically working with Pictera. I am Yajna Senipal Chaudhary. I'm working as an art observation consultant for Scient Geospatial. I'm based at their Reading office in UK. And as my background, I have a doctorate in remote sensing and space applications, specializing in land use, dynamics, and human dimensions of change. In Scient, I am part of the location-based solutions team, where we generate geocoded solutions using Earth observation and machine learning analytics at its best to implement the power of where and how on any business need.
Thanks, Yaj. And to give you guys a bit more background on Pictera, we provide a software platform that enables enterprises to develop their own geospatial imagery-based business applications and services. We have spent the last 6 years helping clients worldwide to scale their ML capabilities and gain new revenue streams. And this helps them to future-proof their businesses like Scient has. So now you have an idea about us. Let's take a look at the agenda, which today is split into 4 parts. So first, we're going to spend 5 minutes briefly recapping the need for geospatial ML Ops. And then we'll spend 10 minutes of discussing 3 ways how geospatial ML Ops empowers companies. And then next, the most exciting part, where we'll learn from Yaj how this works in Scient's geospatial practice. And finally, we'll wrap it up with your questions of the audience. So do pop them in the chat box as we go through today's webinar. And of course, also good to mention, everybody will receive a recording of today's webinar and on demand in the next couple of days. So feel free to share with your colleagues who didn't make it. So let's begin by taking a look at the need for geospatial ML Ops. Essentially, how or why should we care about ML Ops? So hands up if you have seen this stat or a similar one. This widely cited article, thanks Josh, article states that a staggering 9 out of 10 data science projects never make it into production. Yaj, how is your experience in this?
Well, to be honest, I would suggest this value is increasing now gradually. Mm-hmm. And definitely that is because of the cloud native geospatial 2.0 framework that we have these days, as well as the huge amount of data that we are getting access to because of the disruptive upstream space sector as well, with all the next generation satellites and those data and their analytics as well. So, and also along with that, we have an increasing implementation of agile solution approach in our process, in our project development, solution development. So, and that also enables us more and more collaboration between the stakeholders that helps us to pace up the development and the solution validation. So definitely this value will be increasing in the next 5 years as well.
Well, that sounds very good. So how can MLOps help to further speed up this increase and move geospatial machine learning projects past the initial phases and into production? That's the question here. So to go on to the next slide, well, machine learning has started to become more applied and less theoretical. So, and now the industry has begun to incorporate it into important projects. Enter MLOps. So this term may sound familiar, well, for those who have worked on traditional software projects, because it's closely tied to DevOps, the parent of MLOps. So DevOps standing for development and IT operations. And MLOps is a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. When an algorithm is ready to be launched, MLOps is practiced between different people in different teams. So data scientists, DevOps, machine learning engineers, and they try to transition the algorithm to production systems. So how can projects make it out of the initial phase? Well, companies can often treat their data science talent like internal consultants. They create a backlog of requests from the wider company and assign them to individual team members. And that's something you want to avoid. So we need to ensure that data science teams are not siloed and separated from each other. But the upside is data scientists are becoming more visible by their ability to tie their work to business impact. And that's the important thing here, right? So however, the struggle lies in productioning their work due to resource constraints. This could be because of perceived risk and lack of, let's say, certainty, causing their work to lose priority, and therefore greater alignment between business, IT, and data science teams is crucial to readdress this balance. So at Pictera, we are solving this by providing a single SaaS platform to cover the whole lifecycle of machine learning project. And for the ones who don't know, SaaS standing for software as a service, because this allows you to reduce massively the time required for such a project. And now we're making geospatial machine learning projects available for new companies that wouldn't have the budget or the workforce. By providing a user-friendly interface for this whole life cycle, you can imagine this gives them the opportunity to increase their revenue streams, because all those steps from organizing the data, labeling, developing, you need in the traditional machine learning lifecycle, you need specific experience as a data scientist, software engineers, DevOps engineers for every step. So you can imagine every step takes a lot of time, takes a lot of expertise, and with that, a lot of budget. So that's why most of those models don't make it into production. And that's the problem we solve here with Picterra's platform. So here in this slide, this is a pretty busy slide. So let me guide you guys through it. So Pictera provides a full software platform for geospatial ML, all the way from data processing to integrating with third-party reporting software. On the data front, on the left-hand side here, Pictera supports a wide range of data formats and data types. So you can upload any type of imagery data, connect to a WMS server, or even a cloud storage bucket. What you see here in the center, that's the core of the Pictera platform. Everything is based on a rock-solid, cloud-based software infrastructure that brings you automatic GPU scaling and guarantees around security and data encryptions. And as the cherry on the cake, we have the model training and deployment capabilities. So Pictera enables automatically training a custom detector from your training set and instantly make it available to be applied at scale. So we have an example where a client went from training a model to applying it on a whole country scale in a matter of hours. So everybody who's watching, let me know in the chat box if you want to know more about this, and we're happy to share that use case with you. So finally, on the right-hand side, we're looking at how the results you obtain in Pictera can be shared or integrated. So self-served reports and dashboards can be produced along the ability to connect to third-party software, be it GIS or any business intelligence tools. And to go back to you, Yaj, do you have an example of how you have used such a workflow within Scient?
Yes, of course. We have been using this interface for the last 2 years. So we have like mostly as a user, we have applied all of these phases, starting from the image access, ingestions to the platform, then training the data, and also visualization of the data outputs. So in case of data types, I would say like mostly we have been working with optical multispectral data, both RGB and also near infrared bands. And along with that, we have also used some aerial imageries, RGB imageries, and also some open source surface model as well, digital surface models. And most of the database we have used, we have directly uploaded that, and or also we have accessed it from the WMS server directly. So both type of access we have gone through. And then for the annotation part as well, for the training part, we have used both types, like using the annotation directly, building it on top of the platform, and also some other sources of ancillary data that we use for some other projects. We could actually bring it inside the platform to work as an annotation, dummy annotation, which we can improve later on. So that way we have used different types of training data as well. And the most interesting part is in the training phase within the platform, it gives us constant cues and advices, tips on to how to improve your annotations, how to improve, because the more we make the labels precise and qualitative, the more confidence the model has how to differentiate between the target feature and the non-target features. So we have, it's an interesting interface where it keeps on continuous monitoring of those models and also gives us advices how to improve that. And then finally, once the scores, so they produce automatic statistics as well as to how accurate your model is going to be. And based on those satisfactory scores, we then deploy it into a different geography altogether to see how it behaves in a different scenarios. And also at the end, once the outputs are coming out, we can directly download them, or we can access it from other softwares like ArcGIS or QGIS using their plugins. And also for showcasing it, we have used it in ArcGIS online dashboarding and also in other dashboards like Carto visualization as well. So we have gone through this whole process and it works really, really interactively.
Wow, thank you for sharing that. I think that's pretty amazing how you have applied it in practice. Going to the reason for this webinar, let's take a look at the three ways that Geospatial ML Ops empowers organizations as yours.
Sure.
So the first one, and that is by increasing collaboration and communication. So data scientists need to work hand in hand with business and IT. So ML Ops is a collaborative function, often comprising of data scientists, DevOps, engineers, and IT. So by adopting an ML Ops approach, data scientists and machine learning engineers can collaborate and increase the pace of model development and production. So working with business managers can also help to discover new applications for machine learning that will drive business results. In Pictera, data labeling is a straightforward and efficient process. And Yaj also described it a bit just now. And as the complexity and volume of your images increase, so will your need for input from colleagues during the labeling process. So to improve data quality over time, your model must incorporate business rules, context, and edge cases. So collaborative features within the platform contribute to model accuracy improvement by facilitating label auditing. So anyone within the organization with a Pictera account can log in to verify the accuracy of those labels and update them as necessary. So it also counteracts the effects of human error or bias of individual annotators. Is this something that you've benefited from, an increased collaboration and communication within your team, Yaj?
Yes, actually, absolutely. We have been testing and trialing Pictera since 2020, and that was a time when pandemic was actually going on, and in any case, most of us were working from home all the time. And with Pictera, we actually could accomplish during those years, we could accomplish several proof of concepts during that time, and that too working within a multinational team across science. So our team members from different skill sets, whether data scientists or ML engineers or like art observation specialists like me, we were all from different parts of the world, were working simultaneously to build the solution prototype using the same platform, Pictera. So I would say it definitely has a positive impact on building the team strength, the team confidence, and with a very fast pace of product development.
Yeah, and I think a lot of people that are watching can relate to this because, well, in this new world, everybody is working remotely or partially on the office. So despite of your office hours or remote working, yeah, important one to make it possible for collaboration. So the second one, as well as counteracting human error, Geospatial Ops supports the monitoring of the model accuracy to best improve it. Once the model has been trained within Pictera, it can be evaluated using testing and accuracy areas. This model evaluation is an iterative process which, when combined with the collaborative features already described, enables improvement in the quality of training data and thus more accurate results. And the improvement in data quality leads to increased model performance and business users and data scientists can contribute to ML initiatives using our intuitive platform without sacrificing flexibility and scalability. So the image what you're looking at here right now is a screenshot from the Pictera platform where you create your detector, and you see all these types of areas, and these are standing for example, the yellow one. This is where you label your data. This is your training data set. And when you want to test how the model performs, you create a testing area. Those are the red ones. And if you want to know, okay, how is my model performing, and you want to give an accuracy to your team member or to your supervisor or to another team, then you can build the blue area. That's an accuracy area where the model compares your annotations, so your labels, with the model performance and get an accuracy level in a percentage. And that can be in on counting or on a area of coverage. So the third one, this brings us to the third one. And well, this is how, well, let me rephrase that. It's being able to provide effective and quick scalability from prototype to production. So Yaj, you can take over here and tell us how Scient is achieving this in more detail.
Sure. Every solution, whether it is coming out from a business-led or a proactive one, it goes through a defined journey from starting from the proof of concept to prototyping the MVP, and also finally going to the production application. Now, the preliminary effort and time that we spend in the feasibility and the efficiency study of the POC, it actually holds the key for the production scalability. Now, we have seen this, that time and effort has enormously, it has reduced when we use such kind of automated cloud-based platform like Pictera for various of the use cases. We have tested that. And in a very insignificant amount of time, says within days, the model can actually learn iteratively from various examples that we put in. And it gives us, the users or the GIS analyst, the scope to validate and fine tune it constantly. Now, with this, we have actually moved from successful POCs to production for many of our customers as well. So here in the slide, as you can see, there are so many different types of use cases, whether detecting or analyzing crop types and their health, or finding out the different temporal or spatial changes between the rural land surfaces, or the wetland risk assessment for the utilities, or any kind of other man-made features like roads or building footprints or solar panels. We have done a couple of use cases testing in Pictera, and most of it has, like, we have seen that the accuracy has gradually improved, and with proper qualitative training annotations, it can go from, as I have seen, from 60% to 90% as well. So wow, that much improvement is possible. So I can talk about two different use cases here, a little bit more elaboration. So one is for the wetland assessment that we did for one of our utility client, who are actually electricity network provider in California. And for them, we did a vegetation risk assessment with respect to wetland as a sensitive area. And overgrowing vegetation canopies along with these network territory is considered to be the most potential hazard for these utility companies in US. So which once it's spotted, they have to go through some actions like either cutting it down or trimming it down so that they can mitigate the threat on the network poles. Now, before taking such actions, they have to assess whether their action can cause any kind of risk to the neighborhood sensitive areas like wetlands or water bodies for that matter. And what they usually do is they usually send surveillance team to the field, but because of its time consuming and quite expensive surveys, they have to, they are coming back to us saying that whether we can use some automated monitoring for these kind of aspects. And we use Pictera for this. Initially, it was like we took just, can you imagine, just 1 month to test the feasibility. And then we got the, like after the POC is done, we got the project, and we trained with a huge number of annotations throughout the area, and then we extrapolated deployed the model at a very high confidence level, almost 90%. So it was a big hit for that project as well. So another such customer who are like an old regular customer for us, and for whom we have developed a crop and habitat monitoring system. And they are our regular customers from 2015. And this initially we used to provide the service based on the manual data capture or the visual analytics. But later, when we gradually start incorporating the traditional data science techniques like unsupervised and supervised classification, we had to spend still like quite a lot of time and effort, like almost weeks and months to process the data and filter the output to make it deliverable. So now with advanced computer vision learning and cloud computing, we can extract and deliver within hours. So this is one point. And secondly, also there are a lot of dependencies on ground truthing. So ground validation is a big part for traditional machine learning. And we ourselves, we have been sending surveyors every cropping season to validate those crop and their health over the fields in UK. And though it is quite expensive, but we have to validate that with the ground so that we can feed that inside the model. Now, this actually I was testing with Pictera as to how we can reduce this dependency and how we can make it more robust for any geography. And I tested for a few of the main crops in UK, and we trained it from different parts of England, and then we also deployed it in a completely unbiased geography. And I'm happy to say that it actually could detect almost 85% variations of that crop types. So in that area. So the main point is Pictera definitely helps us to reduce our time to market the solution feasibility and invest the extra saved time more on the scalability of the potential ideas into production.
Wow. Thank you for all these insights. This is pretty awesome how you have put it in practice and what you are achieving, because going from 30 to 90% accuracy, that's what we all want, right?
Yep.
Okay, so now I'd like to go a bit deeper into how Scient as a company weaves data science and models into the fabric of their business, and how Pictera enables their geospatial practice. So let's start with a few questions. We are all very curious to hear your side of the story. So to fire some questions at you, can you tell us what was the need for geospatial ML at Scient? What was the internal urgency? And were there any noticeable trends that you observed? And maybe also, did you investigate if you could implement it yourselves? So it's a lot, but I'll leave it to you.
Sure. So, Scient's objective is to help all our customers to solve those problems that matter. And for 30 years, we have been using this geospatial technology to assist companies to find out new and more efficient ways to make these informed decisions. Now, with regards to geospatial sector, most of our customers, they require this location-based intelligence or insights to support their business decisions. And that can range from either environmental health assessment or any utility asset or infrastructure monitoring or their regular ESG compliance assessment. Now, Earth observation from space or aerial is the main resource, or I would say the indispensable resource to derive those kind of insights because of its ability to view and capture synoptic information from Earth without going and inspecting physically over there. So in short, it helps us to extract information about the Earth's features and land covers, their location, and as well as their condition over space and time. Now, machine learning, specifically geospatial machine learning, it helps us to speed up this analysis. It helps us to accelerate this assessment from Earth observation. Now, in the past, we would have done this through mostly by manual data processing, data capturing, or any kind of visual analytics, right? But the huge amount of data that we have right now accessible to us because of all these next-gen satellites. So it literally makes the human-based data processing and analytics impossible to scale up at a regional or at a national level monitoring service. So, and at the end, such kind of traditional assessment used to take weeks to months to generate some output. Now with machine learning operations, we can actually, especially with the cloud native frameworks, we can definitely produce ready-to-use insight within hours. So that is the reason we utilize AI and ML Ops. We need that to accelerate the deliveries for the actionable insights to our customers. And so the main need is rooted at the benefit it offers in terms of saving time from desktop data processing to focus more on actually developing the actual reason why we are doing it, the insight that we want to get from the data so that it can solve the business need.
Wow, thank you for this useful insight. I can imagine if someone has questions about what you just told us. So if anybody has questions, just drop them in the chat box. And I think for a lot of companies, they see the competitive landscape growing. So I'd love to understand how geospatial ML is enabling you to differentiate yourselves from your competitors.
Yeah, of course. The first thing is definitely that makes us stand out is how quickly we can perform a successful POC and implement it. So usually traditional machine learning, it has definitely several aspects or phases of developing it. So it starts with definitely with the data requirements, data feasibility, then processing, calibration of all those data, and then finding the best fit use case or best fit analytics for that use case, because every use case is different, right? So your analytics that you want to use for it also differs based on the use case. So we have to find out that, and then find out the whether it should go for what is the best algorithm to be used for, whether it is object-based, whether it is using machine learning or deep learning. So all these things need some amount of time, right? And for POCs means it's always just it has to be very quick so that we can quickly convince the customers about it and go into the production phase. So definitely, if we have seen it ourselves, usually when we used to take POCs based on basic machine learning objectives, we usually takes more or less 2 to 3 months to finish one, right? But here in Pictera, I have seen myself, like I did it 2 times, and it went into production after only 1 month. So we can speed up the process, and almost 60% of the time is saved because Pictera already has a template ready-made to be used, to be tailor-made for the particular use case. So that is the biggest benefit, I would say. And also, secondly, it's iterative learning and the model improvement, constant model improvement that we can do with that. It also gives us scope for constant validation and if we are going in the right direction or not. And constant support and feedbacks from our engineers to Pictera's engineers is also one thing that I would definitely say. So they are very, very very transparent about that relationship, and we anytime any kind of assistance, we can connect to each other, communicate with each other. And thirdly, all of these things lead us to to build a scalable and robust data models that can be applicable to any geography, and which we have tested from different parts of the countries as well. And lastly, because we are using agile approach in solution designing and execution, so we try to involve the customers as well here, the stakeholders in every stage, so that we can validate our outcomes from our models with their expectations at the expectations at the same pace, you know. So these are definitely the main points that makes us stand out from our competitors.
Wow, that sounds great. So this is a way to stay ahead of the competition. Something other companies can apply for themselves in their own industry also. And then, okay, so you stay ahead of the competition. And how are you driving more value for your clients? Because in the end, that's what it's all about, right?
Of course. So the main benefit, as I was telling, is Picterra's platform is ready-made, very user-friendly, and no code interface. So every use case is different. Customizing an efficient and self-sustaining solution for each, from planning to designing and deployment, it requires a considerable amount of time before we can showcase any of the outcomes to the client. Now, Pictera, as I said, speeds up this process by providing the baseline template on which each customer solutions can be tailored. Secondly, I would say it's the way quicker testing and iterative learning that it does. It can improve the model confidence, giving us, the stakeholder, more time and chance to validate their need and expectation. And third point is, this I can actually vouch myself, because I just now tested it last week. This is something, it can also serve as a quick demo interface. So even this is a stage before POC as well. So last week only we used Pictera for a quick demo for our potential customer. And so that we just wanted to showcase that we can, that use case is doable. So we ran a quick demo on a site selection for a 5G planning, and where we use the model to extract the land zonations based on their land use categories. And these land use categories are mostly on the urban land use. So there was industrial, there was commercial and residential. And can you believe how fast it generated a first come result? It was only 2 days. So we had the nice small area. It was a small area, but it produced a very nice data, which validated with some open source data as well. And so, yeah, so definitely it is a good one for showcasing your demos as well.
Wow, that sounds really great. In 2 days, that's awesome. How do you foresee gaining additional value internally utilizing ML Ops and in Pictera? Because that's also important, right? Because you're collaborating with different teams. Yeah, what can you tell about that?
Yeah, sure. Definitely. First thing is that with this fast pace of creating a project, like creating a POC and then a project, definitely it will help us to expand our geospatial client base so that we can serve more, we can serve better. And this will lead us to also build a sustainable client relationship by our robust cloud agnostic solutions. And finally, I can say that we can improve our collaborations and communications internally between different skill sets, between different teams, including ML engineers, data scientists, IT, or EO analyst as well. So definitely, we can use that as a platform to collaborate.
Wow, thanks, Yaj. Awesome. Thank you for sharing. We're a bit over time here, so everybody who's watching and you have any questions, if you're watching right now, share your questions in the chat box, or if you're looking at this recording, feel free to use the email address you can find on the last slide. So many thanks to you, Yaj, for giving us those fascinating insights. Finally, let's go to the questions of the audience. So please make sure to type them in the chat box. And of course, the ones we don't get answered will be followed up on personally. So let's see if there are any questions.
I see one question here.
Yeah.
It's asking about what kind of geospatial data do you work with most, whether it is Earth observation like SAR data or LiDAR, etc. So yeah, Scient has been working with geospatial data for 30 years, starting with mostly aerial imagery. But we also do have other like satellite images as well, multispectral, hyperspectral. In my tenure with Scient, I have mostly been involved with satellite and aerial image analysis. And have used multispectral as well as some sort of, in some based on the use case again, some use cases we did use SAR at the same time, some hyperspectral as well. So far in Pictera, I have used mainly the time series data, multispectral, with some open source digital elevation model that we primarily use to enhance the detection capability of the model. Yeah.
Yeah, thanks. And if there are more questions on this subject, let us know.
Sure.
I saw another one coming in. Can Pictera be integrated in my workflow via a public API? Well, even though Pictera is accessible to everyone, and no coding skills are required to train machine learning models, we also make our API available to developers. So train a model using our user-friendly graphical user interface, and call it from your own application to deliver value to your customers faster. So typically you create a detector on our platform, and once you've created a detector, you go into your, for example, let's say ArcGIS. You go into ArcGIS and you basically from there you trigger the detector and get the results directly into your ArcGIS without leaving the portal.
Great. I see another question as well. Are there any specific industries or use cases where you are seeing increasing demand for geospatial solutions? I would say, yeah, with the increasing demand in ESG goals and certification, different industrial and research sectors varying from whether it is agriculture to utilities, mining, or infrastructure. Whoever uses the natural resource or capital as the main ingredients of their business will have to compliance to the ESG goals, and which we can only monitor effectively using location-based geospatial technologies. So automatically, there has been a rising trend and expansion of geospatial services in most of the sectors. And also in addition to that, we, with the onset of these cloud native frameworks, data warehouses, and a disruptive space sector, we have seen an exploding market for geospatial data and analytics that can extract real-time information to locate and monitor any feature or phenomena on the planet.
Great. Okay. I'd love to answer a couple of more questions, but we're on time. I'm looking at it, but I don't see small questions to answer. So the most answers will take more time. So we'll follow up personally. Let's go to the key takeaways from this webinar before wrapping it up. So we've seen and heard that Geospatial ML Ops is crucial to help machine learning projects make it out of the initial phase. A software platform such as Pictera allows companies like Scient to build applications and services at scale with massive amounts of data that are integrated with existing workflows. So Pictera provides a unified geospatial ML platform that greatly reduces the time to market and increases the scalability of geospatial ML operations for customers. So by having all of your data in one self-service platform, you can prototype faster, produce more models, and penetrate customer accounts more deeply. And make up for a lack of data science skills by automating and simplifying your workflows and ultimately provide more value to clients. So, guys, that's a wrap. Thank you so much, Yaj, for joining me today. And a big thank you to all of you who have attended. Don't forget, there will be a recording of this webinar along with the slides that will be sent to you in a follow-up email. Thank you very much again, and enjoy the rest of your day.
Thanks a lot, Joy, for this insightful session. Really happy to be part of it. And I'd like to echo with you. If anybody has any question, please connect to us. We'll surely get back to you as soon as we can. Thank you.
Bye, everybody.
Bye.